Hi, welcome to howtostats.com. In this video I'm going to perform a Kruskal-Wallis analysis. Now a Kruskal-Wallis analysis is basically a generalization of the Mann-Whitney U test, or the Wilcoxon rank sum test, which I've already uploaded a video on. So in the Mann-Whitney U, or Wilcoxon rank sum test, you're only comparing two groups based on ranked data. And in the Kruskal-Wallis, it's a generalization to three or more groups. I'll note that the Kruskal-Wallis is applicable in the two-group case. You can do so perfectly justifiably, just like you can in a one-way analysis of variance using the ANOVA, one-way ANOVA, on the difference between two means. You can do that instead of an independent samples t-test. It's perfectly legitimate. But if you have three groups, you can't do a Mann-Whitney U. It's only restricted to two. And now in this case, I've got three groups, and this is basically very similar data to what I performed in the Mann-Whitney U case. But I've changed the example a bit, and I've actually changed the data a bit too. And what in this fictitious example I'm going to be looking at is the number of drinks consumed in individuals who have problem drinking across three locations that are providing some sort of treatment to help people overcome their problems with problem drinking. All right, so there are three groups, and the groups are demarcated in a single column. So location 1 is demarcated by 1s, and then I've got 2s for those who are at the second treatment group, and I've got 3s for the people that are in the third treatment group. Now these are their number of drinks consumed, let's just say on an average daily basis. And so there's 15 people that have been randomly selected from the third treatment group to actually ask them how much they've been drinking on average over, let's say, the past week. And here are their numbers. So some people are not drinking at all anymore, and these people have relatively low levels, and these people are still drinking quite a bit. And there are three groups. Is the second group data. These are the individual data. So individual 1 is drinking 0, and individual at case 15 is drinking 22 standard drinks a day. Now, these data are not normally distributed, which is obvious based on the number of zeros. There's a lot of people who aren't drinking, well, there's, relatively speaking, a number of people drinking 0. So this is obviously going to skew the data. And we can take a look at that, and that's actually the power of the Kruskal-Wallis, is that it does not assume normally distributed data, whereas the analysis of variance does. I'm just going to very quickly look at these data. So I'm going to split the groups so that I can actually look at the data in a split form easily. So I'm going to go into descriptives, and I'm going to look at drinks, and I'm going to look at a histogram, and I'm going to look at the actually I'm probably going to look at the skew and kurtosis, and maybe the standard deviation. Okay, so here are the data in descriptive statistic form. We'll look at the distributions first. So here we can see this is clearly not a normally distributed set of data. The zeros is the mode, and we've got a positive skew. For the second group, it still looks a bit positively skewed with the tail going out, but the mode isn't 0. The mode is actually something like 10. And in the third group, we have a very, very similar distribution to the first group. And in fact, I'll note that an assumption of the Kruskal-Wallis, just like it is for the Mann-Whitney U, is actually that the distributions are actually the same. So it doesn't assume that the distributions are normal. That's not a problem. But it does actually assume that the distributions are similar. And the only way you can really test that is, taking a look at the skewness levels. So we've got for location 1, skewness of 1.4, skewness of 0.65, and a skewness of 1.43 for the third location. So they're all positive, roughly the same, but location 1 and 3 seem to have more skew. And you can look at the kurtosis as well. The kurtosis for 1 and 3 look very similar, although location 2 has negative kurtosis. Whether that's statistically significantly